Hey guys, welcome to brainAttic. So today we have another set of interesting problems from the topic of limits, continuity and differentiability. These problems are not very challenging but are very tricky to solve, and a mistake here and there will cost you. These questions are of the type of JEE Main and IMO level 1. So if you do want to give it a try, you may pause the video now and give it a try. Otherwise, let's continue solving the problem. So we have three questions. In the first question, if f of x is an increasing function from r to r such that f double dash of x is greater than 0, that is double differentiation of x is positive, f of x is not equal to 0 and f inverse exists, then we have to find whether the double differentiation of f inverse x with respect to x is equal to 0, b less than 0, c greater than 0 or depends on fx. Next question is if function r to 0 to infinity be such that f of x plus e power x plus x square divided by f of x is less than equal to e power x plus e power x square for all x where x is positive, then we have to find the limit of f of x when x tends to 1. In the third question, if f is twice continuously differentiable such that f of 0 is equal to 1, f dash of 0 is equal to 0 and f double dash of 0 is equal to minus 1, then for all a belongs to r, that is real number, limit x tends to infinity, we have to find f function of a under root x whole to the power x. So let us start solving the first question. Since question A, I'll just take a different color. Since f is an increasing function, so f dash of x is positive and f double dash of x is positive are given. Now let g of x be equal to f inverse of x. This, then we can say that function of g of x is equal to x. Now this will differentiate with respect to x and we'll get f dash of g of x. By chain rule, we'll have g dash of x is equal to 1. Again, we can say that g dash of x is equal to 1 by f dash of gx. Now, we'll again differentiate with respect to x on both the sides, and what we'll have is g double dash of x is equal to minus 1 by f dash of g of x whole square into f double dash of g of x into g dash of x. Now, since f dash of x is positive, which means f dash of g of x is also positive, this implies. And therefore, g double dash of x, since this term is a positive term, this we know is positive, and this we showed is positive. Therefore, the negative term, because of this negative term, g double dash of x will be negative. Therefore, and this is what we are asked to basically find out. So for question A, the option is less than 0, B. Now going to the next problem. Let function f be defined over r to 0 to infinity, and this is the inequality given. We are to find the limit f of x. Now we'll simplify the inequality a little. Simplifying, this is for question B. Simplifying the inequality, we get fx whole square plus e to the power x plus x square is less than e power x fx plus e power x square fx. Now this we can rewrite as minus e power x fx minus e power x square fx plus e power x plus x square is less than equal to 0. Now we'll take the terms common, and by factorization we'll land up with f of x minus e power x into f of x minus e power x square is less than equal to 0. Now, if you're not familiar with this formula already, if x minus a into x minus b is less than 0, less than equal to 0, so this implies that when a is greater than b, x will lie from b to a, and when b is greater than a, this will imply that x will belong to the range a to b. So basically what we have from this inequality here is fx will basically lie between e power x square and e power x when x belongs to the range 0 to 1, and it will lie in the range e power x to e power x square when x is greater than equal to 1. So the limit asked to us is limit x tends to 1, f of x is nothing but e. This is our answer. Now let's head for the third problem. So this we have found is equal to 1. The third problem is if f is twice continuously differentiable such that we are given f of 0, f dash of 0 and f double dash of 0 when a belongs to R. So we have to find this limit. So let us begin solving the problem. Now we'll call this limit while solving for third question. Let L equal to limit x tends to infinity f of a under root x to the power x. So we'll taking log on both sides. Log on both sides, we get log, I'll write it in a different way. Log L is equal to limit x tends to infinity x log f of a under root x. So here you see, right, the power x has come in front because of the properties of log. Now we take, say, x is equal to 1 by t. Then we have log of capital L is equal to limit t tends to 0 positive, that is 0 to the positive side of the real number axis, log of f a under root t divided by t. Now we know L'Hospital's rule, and it's applicable when we have a fraction which is of the order 0 by 0 or in the indeterminate form. So we'll apply L'Hospital's rule, and what we get is log L is equal to limit t tends to 0 a f dash of a root t divided by 2 root t f of a root t. So again, if you put the value of t in the fraction, you will find this is still in the indeterminate form, that is 0 by 0. Therefore, we'll again apply L'Hospital's rule. L'Hospital's rule. Now when we apply L'Hospital's rule, we have log L is equal to limit t tends to 0 a square f double dash of a under root t by 2 root t divided by 2 into a root t by 2 root t plus 2a root t f dash of a root t by 2 root t. Now this 2 root t will cancel, and what we are left with is limit, we are writing the left hand side. So this is log L is equal to limit t tends to 0 a square f double dash of a root t divided by 2f a root t plus 2a root t f dash of a root t. Now we apply the limit and we are left with is a square by 2 minus. Therefore, e, now we take the log, we apply the exponential on both the sides and we get L is equal to minus a square by 2, and that's our answer. So if you do like the video, hit the like button, subscribe to our channel for more content like this. Thank you so much for watching.